Today, we're exploring the fascinating and highly secretive ecosystem of Iran's military technology. We're going to look strictly at the history and the data to see exactly how they've constructed a genuinely formidable defense structure, basically by blending their own domestic production with foreign technology. So, here's the central paradox we're unraveling today. How on earth did a country that is entirely cut off from global arms markets manage to build the largest, most diverse missile arsenal in the Middle East? I mean, despite decades of strict embargoes, their defense space didn't collapse. Instead, it actually evolved into this highly specialized system for asymmetric deterrence. To make sense of all this, we'll break this geopolitical puzzle down into 5 quick chapters: the sanctions paradox, reverse engineering, domestic innovation, hacking supply chains, and finally, the asymmetric threat. Let's get right into it. Part 1, the sanctions paradox. To really wrap your head around the sheer scale of the situation Iran is operating within, just think about this staggering number: 3,000. Military estimates suggest Iran maintains an operational inventory of over 3,000 ballistic missiles. You see, because they've historically lacked a modern air force, they basically poured all their resources right here. They prioritize building a massive arsenal as their primary way to project power. Moving on to part 2, reverse engineering the arsenal. Now, they obviously didn't just build this from scratch out of nowhere. Back in the 1980s, Iran imported Russian Scud-Bs to fill some immediate tactical gaps, and they promptly started reverse engineering them. Then, by 1989, getting their hands on Chinese M7s gave them this crucial early foundation in solid-fuel TEP. Fast forward to 2001, and you have this secret black market acquisition of 12 nuclear-capable K-55 cruise missiles from Ukraine. By the 2010s, they hadn't just copied those designs, they had fully reverse-engineered the airframes to create their own ground-launched Sumar cruise missile. So the really key takeaway here is that dissecting foreign tech wasn't the end goal for them at all. It was just the launch pad. They take a platform, figure out how it ticks, duplicate it, and then they iterate. Imagine taking an air-launched missile, strapping a solid propellant rocket booster to it, and suddenly, boom, you have a ground-launched weapon perfectly tailored to your own strategic needs. It's incredibly resourceful. Which brings us to part 3, the domestic innovation push. That intense drive for self-reliance triggered a massive shift away from clunky liquid-fueled missiles toward modern, solid-fueled weapons. And why does that matter? Well, legacy liquid-fueled systems require these long, totally exposed fueling sequences. It basically makes them sitting ducks for enemy aircraft. But solid-fueled missiles? Those can be stored fully fueled in underground bunkers, ready to roll out and fire in a matter of minutes. It is an absolute game-changer for survivability. This domestic evolution ended up creating distinct families of weapons, covering basically every tactical need. You've got the Fateh family, acting as the backbone for highly accurate short-range ballistic missiles. For the medium-range systems that need to reach deeper into the region, they rely on the liquid-fueled Shahab and that highly survivable solid-fueled Sigil we just talked about. And rounding out the whole shebang is the Sumar family, giving them low-altitude, sea-skimming cruise missiles designed to slip right under enemy radar. And honestly, the innovation literally hasn't stopped. It's now reached the hypersonic tier with weapons like the Fateh. So instead of flying in a predictable ballistic arc, the Fateh is specifically designed to perform these erratic mid-course and terminal atmospheric maneuvers. It's built to dodge, weave, and ultimately overwhelm advanced regional air defense networks like the US Patriot or Israel's Arrow system. All right, part 4, hacking global supply chains. Okay, this is where the story gets really wild. To build these advanced weapons, Iran effectively hacked the global commercial market using a resilient 4-part procurement web. We're talking front companies with spoofed emails, routing materials through Chinese re-export hubs, exploiting the legal ambiguity of civilian dual-use tech, and engaging in direct state-level tech transfers, like their recent drone deals with Russia. And the results of this procurement web? Absolutely staggering. Despite facing some of the strictest sanctions on the planet, when task force investigators pull apart downed Iranian drones like the Shahed, they find that 82% of the internal microelectronics originally came from the United States, Europe, and Japan. Let that sink in for a second. What's absolutely wild here is that we aren't talking about top-secret James Bond spy gear. They are literally weaponizing the exact same components you or I could add to an online shopping cart today. A German Infineon transistor that you can buy on eBay for $20 is literally running the power systems of their loitering munitions. It is a brilliant, if terrifying, adaptation of off-the-shelf civilian parts. Which leads perfectly into part 5, the asymmetric threat. This incredibly clever use of commercial parts gives them a massive financial advantage. 20 grand. $20,000. That is the estimated cost to produce a single precision-guided Shahed loitering drone. In the realm of global military hardware, that is essentially pocket change. Now, hold that 20 grand in your head and contrast it with the cost of a single advanced interceptor missile required to shoot that drone out of the sky. $2.5 million. Just do the math there. Adversaries are forced to burn $2.5 million just to destroy a $20,000 target. There is no way that's a winning formula for the defense. This massive cost exchange asymmetry is literally the core of their strategy. Iran can launch these saturation strikes, just endless waves of cheap disposable drones, to intentionally exhaust multi-million-dollar defensive systems. Once those expensive interceptors are depleted, then they follow up with heavier precision ballistic missiles. It makes conventional air defense economically unsustainable. So it really leaves us staring at this incredibly provocative question. What exactly is the future of global arms control when open-source tech and cheap eBay parts can be weaponized this effectively? If a sanctioned nation can build a massive, highly capable arsenal just by hacking commercial supply chains, well, the entire global balance of power shifts overnight. Think on that. I hope this explainer has given you a really clear view into the architecture of this hybrid defense strategy. Thanks for joining me.